So hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 115 and in this video we want to talk about reference again, about variables again, but more like how we create references and variables behind the scene. What happens behind the scene? What I mean with that is storage. Their memory, what happens there? We have not really talked about this one. We have just learned the use cases, which is normal. That's that's the thing which you need. But we need now a little bit background because that's very important in this case. Normally we don't need any memory background, but when we talk about references, actually we need a background. And to get this background, let's get started. And I start with a variable because I could start also with a reference, but to this point we will come. First we have to understand a variable and then we will understand a reference also. So let's start what we know. Here is an int, here is my telephone number. And here's my assignment operator, which is a copy operator. And then I write the value. This is my telephone number. Let's make it a little bit short. And you see, now I copy this whole thing here also. Now you see we have created what we already know, a variable. We assigned a default value to it. And that we know. But what we don't know right now, or at least I have not talked about it, how this one is created behind the scene. What I mean with that is, what is the compiler doing to create this variable here, and how is it assigning? And we will not talk this in depth because this one is, let's say, not too complicated, but you need to read this again in theory, which means you need a good C++ book or good online pages where they explain all this kind of stuff more in depth, accurate, because I make here not accurate explanation. It's more like an explanation so you can understand it, all the important parts. So we will need this for future videos because we will talk about pointers and we need a little bit knowledge about storage, memory and memory addresses. That's why I'm going to do this. So let's continue. So we have created a variable, we know it, but now we need to know it a little bit more in detail. And for this purpose, I open up my Paint. And it's not very difficult. What I make is, again, I copy this one here first. I open up Paint, I paste it in, and now I explain a little bit, absolute not accurate, because this one would go too much in depth. I make it a very simplified explanation what happens behind the scene, right? So in technical terms, let's get started. First of all, we know when we create a variable and this numbers here behind the scene, they will stored in memory. Memory is like our hard drive, just another type of memory. For example, we have RAM, read access memory, and then we have ROM, read only memory, and there are many kind of memory. Memory means in general it's another way to store variables, to store data, like your hard drive. Hard drive is only a little bit slower, that's why they don't use this one, and they have not all the features of a RAM and so on. So you just need to know when we talk about creating a variable, you need to store it anywhere and later you can take it from there. And we call this just memory. And then of course we have to specify which memory, but in our case we call it just memory because we don't need to go in detail right now. So, okay, the first thing we know it, okay, this one will be saved in a memory. And now I'm going to create one memory, how this variable is saved. I try my drawing. My drawing is awful, but I hope you will understand it. Okay, let's get started. I create a variable. And when I create this one, I need the information what you can see here. The primary information is this variable name, okay, the value, okay, and yes, there are some more informations, but in our case, simplified, we care only about the variable name and the value. So I need a storage for the variable name and the value anyhow. Let's create it. I make it here on the bottom, and my storage is this one. I made it. But what you can see right now here, let's say I save now this one here, we have here a problem, right? When I make this one like this, I can save here only one thing in it. For example, I save it my telephone number here, or I save my value here. So a memory, let's say this variable is not created like this, what I showed you here. It has more, let's call it layers. This layers, it has not layers. This is just to simplify, to understand how it works a little bit easier. It's not accurate, but let's call it has layers. So for example, I need more information to pack in. What I can do now is, okay, I need this my telephone number, okay, I need this value. Let's make it 2 layers, but it's still one storage, right? It's one memory place. It is one place where I want accesses. But I save now there my telephone number and the value here. Perfect. That fits. And that will work almost. But in real, that's not the case. And the reason for that is this, my telephone number here. This one is not really used here by creating the storage. Why is this not used? Because the storage, for example, the memory, is providing you something. For example, it says this memory says you, I have only here memory addresses. You can only use memory addresses, and in this memory addresses you can save this value. So I don't know what you want with this variable name. I don't care about this. So the storage says, okay, give me your value. All right, let's give it here. That's okay. Then it says, the storage says, I don't know this created variable name that we created just like we wanted, right? We can variable names call what we want, change what we want, and so. But the storage, the memory address say, I have fixed addresses. And they are different, but if you want use this variable, you must use my memory address. And I give, for example, this memory address right now, this memory address, and they look very strange and we don't understand them most time. There are some random memory address numbers. It's not very important. Of course, if you have experience, then you know what they mean or less, but I don't know right now what they mean. I see here only strange numbers, and these strange numbers are representing a memory address in your PC. And the storage says, okay, if you want to use this value, this 532, I saved it in this memory address because I don't know your variable name, what you created. That's a problem for a programmer, right? We are working only with variables. I mean, a programmer is, without variables, we can't work. So there needs a solution, and the solution is very simple. We add one more layer. And this layer says, okay, you have only memory addresses. Okay, this one here, I can save now my value. Then in this layer, I write now my telephone number. So as an additional information, okay, let's write here my telephone number. I write it. And all right, and when the compiler later tries to find my telephone number, for example, it will try to access this is one storage place, only one, right? Whole thing is only one thing here. One. It's one storage place. It has 3 layers. All right, we have here the 3 layers. And when now we call this in our program, anyhow, then behind the scene, it will try to find the right storage. And how it is finding now the right storage, because I said the memory has only this memory addresses. And how is this connected now to this my telephone number? What is doing this? So actually here this layer and this layer get also a connecting from top to down. This telephone number which we created here in our coding section, which can be anything, will be associated with this memory address, because the storage knows only this memory address later. He cares only about this one here. And if you want something from this memory address, then you can have to know this memory address. Okay, we can now, our name here, this one, my telephone number, I associate it with this memory address. And that's the way what happens most time in programming, or let's say it's not accurate, of course not, but you can think about it. All the names what you create will be later associated behind the scene with a memory address. And then this memory address has a value. So, and when we say now behind the scene, they say not the variable has a value. No, they say the memory address here has a value, which means this way, right? So they say this memory address has this value 532, not this telephone number. This telephone number is associated with this memory address, and this memory address has this 532. And I think that's enough what we want to learn. You see, that is absolutely not accurate, but it's very simple to understand what we want what we need for our future things, because I made this for a very, very certain reason. And this reason we will talk. So think about it one more time. When we create a variable, think about we make it is one storage place, and this storage place has the most important part here is this memory address. It creates a memory address, and your variable name is connected, associated with this memory address, and this value is also put in. They say all time put in this memory address, but you see it is like it is associated with this memory address, and all time when we try to find anything, it will jump to this memory address behind the scene and find it. And here one more time, so you can see behind the scene it works not like in front of the scene. In front is our coding. In front we see just the variable name. We care only about the variable name, and then here the value. That's enough for us. So even here this variable name, and behind the scene the compiler cares only about this memory address and all the associations here. What is now here associated with what? And that's good. The question is here. There is one interesting question. Wait a minute. If this is so, why we don't use all time here the memory address when it's so important? Why we not skip this this variable here? That could be a very interesting question. And that would to answer this question, it's a little bit let's say not too complicated, but there are different answers, and one simple answer is this memory address, what we have here, it's not all time the same. What I mean with that is, we will explain this a little bit more in the future, because this memory address, let's say you start here this program here, and when I start this program here, right now I have started it, right? This memory address, what this variable has, is now any number what you saw. But when I close this and start this one again, the memory address of this variable is not the same. And the question is, wait a minute, why is the memory address not all time the same? And this is again has nothing to do with programming. This has more something to do with memory management of the operating system. The behind the scene, for example, Windows checks your memory and says where I have space to put in data, right? And then the operating system says, okay, right now I have here space, I put you here. Right now I have here space and put you here, which means every time when you start here your program, behind the scene, not this coding thing and not the compiler, your operating system checks first, makes space or shifts memory back and forth, and your program, when you start, it checks where I have memory to create this one. That's why this one will change all time. So if this one is changing all time, that's why sorry, that's why we have these variable names, because they are not changing at all. We can use them all time if we want refer to these variables, right? That's very easy. That makes our life very easy as a programmer, and that's why we don't care about memory addresses, because they can change like they want. As long as I know this name here and I know that this variable name has this value, then it's all fine. And we don't care about this memory address, but like I said, behind the scene, the memory address is very important, not our variable name, because the variable name will be associated every time you start your program with a memory address, and your value will be associated also with this new created memory address. And yeah, that's so the very, very basic, not accurate to understand this one in detail. Of course, you have to read now a little bit theory. Go not too deep as a beginner, because that can go really technical, really complicated and so on. Try to understand at least what I try to say here. And if you understand this memory address, that's enough, because that we will use in our future videos. I think this video is already too long, so I go in the next video for references, because actually, let me show you this one. We have talked about references, but also we can call the reference. We have not talked to call a reference directly. What I mean with that is, let me show you this fast and then I stop this video, which is we learned to create a reference and reference and my referenced variable. Yeah, well, this one we know, right? And then I referenced, for example, because this one is a reference, I need an existing variable already, because refer means I refer to an existing variable. In this case, I created already a variable, so I can refer to this one. So let's create this, my telephone number. This one we know. And so far it's all good. But what we don't know, what we have not talked about this reference is, we can call actually the value of a reference. And what I mean with that, careful, not this one here, as it is say out. What we know is, okay, the value of this reference, we have talked about this. Is this not just my reference? My reference variable, yes, we have talked about that. Oh, come on. And yes, we know this. What is the problem? I mean, we have talked about this, and we know this is 532 because we learned a reference means this one is this one. But what I mean, we call a reference value here is when I write this ampersand here in front. Now I'm not calling the reference value, I'm calling more the storage place of the reference, and that is exactly this one here. when we will learn this a little bit more in detail, that's why I made, when you use this ampersand here in front and then call this variable name, you are not calling the variable value, you are calling where this variable is saved, the memory. And let me show you at least this one, and then I stop. When I start now this one here, and you see now this strange number what I said. It comes there as strange number in my case, and this one will all time change. Let's copy this one. I show you this one also. I said this value will all time change every time you start your this program. Right, let me show you this one here. I said here, every time you start this reference, which is behind the scene, very important, this will be changed. And exactly that I mean. Now I saved here the value, that was this one. Now I start it again. And let's see if this value is here again the same. And what we see now here is, it can be by randomly perhaps the same, but in general it is not the same. And here it is a little bit different. Right now I have here a F, it was here a 9, and a A, okay, this is similar, and then I have here DC, and you see the register, the save place is changed. That was this one here. This is changing behind the scene every time you start your PC, because they try to find free space and then they assign it there. And yeah, I hope that was not too complicated, because that is later what we talked here, what we will talk here a little bit more when we talk about this reference. But actually it is exactly that what I want to show you. And this one becomes more and more important, because soon we will talk about pointers, and this one, this understanding this storage place will become very important. And one last note, this storage place, that's the point where it is distinguished between other languages, because other languages don't care about the storage place so much. So for example, they don't care about the memory. We in C++, yes, we care, and we have to learn this. And yeah, that's why I say you should read a little bit about at least this memory addresses, because we need this in C++. For example, other languages, there are some who have no memory management, and they don't need that. They just skip this all things. But this reference and soon pointers, that makes C++ very powerful and very fast. And I think I talked too much. I hope it was not too complicated, but believe me, this, if you understand my little my little demonstration here, which is not accurate, careful, this is just try to explain this register a little bit in a very easy way. If you understand this little bit, then you will understand the coming videos too. And yeah, with that said, if you have any questions or any complaints, like all times, write it in the comments, and see you in the next video. Bye.